Good evening. It is Wednesday evening. It's the 7th of August, and this is going to be a update to the video I made on Sunday to talk about how Tropical Storm Debbie is going to impact the UK in terms of how it's going to interact with the jet stream and how the downstream implications of that are going to affect our weather. There has been some change in the forecasts reasoning over the last couple of days, and I'll briefly go through how that's going to play out. So this is Debbie at the moment, just off the southeastern coast of the United States, and there had been model disagreement as to whether it was going to track into North Carolina, South Carolina, or even back into Georgia, and it now looks like it's going to accelerate in this kind of direction up the I-95 corridor in towards the Great Lakes of the United States, and we can see that on the GFS. The models have come more into line. Now that has implications with regards to where it enters the jet stream, and if I leave the track on there, you can see that if I run the jet pattern, the tropical cyclone injects energy into the jet stream at a slightly different location. It was going to enter the jet further down here in the center of the jet, or even closer over to the part of the jet over in northeastern Canada. So it looks like it's going to enter the jet nearer to the right entrance of that jet, and that's going to cause it to buckle over Canada. And as it buckles, that's going to force a veering of the jet from the northwest down over Newfoundland into the central Atlantic. So that's quite a change from what we were talking about on Sunday, where we were talking then about a more zonal jet. What we're going to see now is a jet that's going to dive more down towards the southeast, and you can see that if we run through the sequence, the jet isn't zonal. It is in fact going to dip in the central Atlantic, and that's going to create a trough in the central Atlantic. And the downstream implication of that is it's going to force a ridge to build over Western Europe. So the jet is going to buckle, and it's going to force the jet north over Europe, or to the northwest of Europe. And we can see that the model has changed quite significantly. And if we look at this particular chart for Sunday, the red here indicates where there has been a 48-hour change in the 500 millibar geopotential height, and anything in red signifies that over the last 48 hours geopotential height, or effectively pressure at 500 millibars, has effectively gone up in the model. So you can see that there has been a trend for the model to build pressure over northwestern Europe, or build geopotential height over northwest Europe over the last 48 hours, and that's as a result of the jet pattern that we spoke about there. So we're going to create this dip in the jet stream, and that is going to force this ridge to build over northwestern Europe. Now you'll also see that as this part of the jet is actually faster, so you can see the air is going in here faster than it is coming out. So because you've only got yellow and orange here, but you've got deep reds in this part of the jet. So what actually is going to happen here also is you're going to get a lot of air that's going to come streaming into the central Atlantic trough, and then it has to go somewhere. It isn't going to exit the jet at the same speed as it's going into the trough. So that means that the air is going to pile up. Air has to go somewhere. There's only one point of air. There's air for one point of every bit of air of the atmosphere. Around. So that air that's coming, there's a lot more air piling into the trough than there is coming out of it. So that air is going to compress, and what we're going to get is descent that's going to pile up in the region of Biscay. So you can see some of the air exits here, but a lot of air is coming into the base of that trough, and it's going to exit and pile up over Biscay. And where you're going to get that compression, or that descent of air, you're going to get it warming up. And if you compress air, you warm it up. So effectively, you're going to get some quite warm or even hot weather. And there's already hot air that's in place over northern Spain and over Biscay as well. So that's the jet pattern is going to enhance that temperature, that very warm air that's already over Spain and Biscay as we go through the weekend. So if we just run the pattern a little bit further, we get this trough comes east later on Sunday and into Monday. And there's been quite a bit of disagreement on how active that trough is going to be. But if we look at the temperatures first of all, we can see here both by the icon. So this is the German model. You can see as we go through Saturday, you can see that air over Biscay there. You can see the very, very warm, dark orange colours. That is the air is already hot over Spain, but the air piling out of that jet from that trough is going to pile up and descend is going to happen over Biscay. But it's also going to make it quite stable. So when we're talking about that air coming north on Sunday into Monday, it's going to be quite hot, and we're going to see 850 millibar temperatures, probably breaching 20 Celsius across parts of southeast England. So I wouldn't be surprised to see the Hurst-Monceau ascent see 850 millibar temperatures as high as 21 to 22, maybe even 23 or 24 Celsius. Models sometimes overdo this range. They overdo the extent of the very warm air coming into the southeast, but certainly I think over 20 Celsius likely across parts of the southeast. But that air is going to be quite compressed. It's going to be quite stable. And if we're talking about thunderstorms developing later on Sunday and into Monday, we need something to trigger those. We need some colder air to come in aloft, because otherwise you're just going to create a huge amount of convective inhibition and a stable atmosphere. So we need to see whether a trough is present in order to come in. If we look at the GFS 500 millibar chart for later on Sunday, so this is from today's run, no, it isn't. If we go forward, this is from today's run. So this is as of 6 o'clock on Sunday, and I want to draw your attention to one thing, and that is the shape of the trough in this area here. Around the Isles of Scilly and northwest France. If we go back in time, you'll see here the 582 millibar line, dam line, and the Isles of Scilly is between 576 and 582. If we go back over the last few runs, you will see that the trough, if we go back to midday yesterday, you will see that the 576 dam line was through the Isles of Scilly. So there has been a trend, and you'll also see it slightly sharper here. You see more of a trough into the west of here. You see more of a trough, more of a kink in the upper level flow. And if we go forward, you see that becomes flatter. And this ridge is more pronounced. It's more of a dominating factor through the model cycles through today. And what we're seeing is this vorticity or this trough be further delayed out to the west, and also because this is flatter, there is less digging down of this trough. There's not much troughing here, which means there isn't going to be much cooler air aloft coming into the west of the United Kingdom, or rest of the British Isles, as I should say, coming in later on Sunday into Monday. So that means the risk of thunderstorms on these particular runs has actually decreased. And if you look at some of the forecast products, the icon really doesn't have anything at all breaking out. It is not interested in any kind of thunderstorms breaking out, because the air is warm. There is no particular trough coming in, and if you look at the GFS coming in now on Sunday, you've got some thunderstorms breaking out from the English Channel up through the Midlands back. But if you look at yesterday's 1800 run, there was much more active thunderstorms breaking out. So you had pretty intense thunderstorms breaking out on the model from the 18Z run. That isn't so much there today, and there has been a trend throughout the last three runs for this trough that I showed you on the model to be less pronounced, and for there to be more upper level ridging across the southeast. But at the same time, the ridge is also becoming flatter, so it's moving away southeastwards, and the GFS is quite keen to take away that heat from the east and the southeast, and we can see that there on the chart. It moves it up into the south, it moves it away into the continent, and we're kind of back to Atlantic fresher weather coming in by the middle of next week. And this actually, this area of low pressure will contain the remnants of the surface circulation of Devi, or at least its low level moisture from where it is currently in the United States. So a very complicated picture to come. It does look like it is going to get hot. If we look at some of the maximum temperature charts, we're likely to see temperatures of upper level temperatures of around 21, 22 at the 850 millibar level, and we could easily see temperatures of around 30 to 32 degrees Celsius easily in the southeast. It depends on how much cloud cover is also in that trough. As it comes east, it's not particularly easy to stay at this side. The icon certainly going for temperatures on Monday of 32 to 34 degrees Celsius. I don't see any reason why that can't be realized. It's highly likely to be the hottest day of the year across a large part of the southeast of England, but it really is only going to be, I think, that southeastern part of England. Certainly most places are going to have across England and Wales are going to have a fairly hot day on Sunday. Temperatures around 26 to 30 degrees Celsius, and then on Monday that heat, and it will be quite, as I said, quite intense heat, 32 to 34 Celsius probably across the southeast, depending on cloud cover, but it is all going to go as we go into Tuesday and Wednesday. I'll provide further updates on Twitter over the next few days, but thanks for watching.